Welcome you all for the session on conversion of isometric view to orthographic. Let us see a problem today wherein we will be converting the isometric view of a bracket onto an orthographic view. So as you see here, this direction makes you to be the front view. Okay, so along with this front view, I'll be going for another two views. One is a top view, another one is a left side view. Okay, so let us go to. So as you see, when you're starting for the front view, the faces will be visible are this face, the one which is inclined, and the one which is standing right up here. Okay, so along with these two faces, this curved face, that is the bracket face, will also be visible. Okay, so these three faces will be visible. So let us start. So let us first draw this face. Okay, so here this face is 115 mm in length. Okay, and this face is 60 mm in height. So this will be your faces, this inclined face and the vertical face. Okay, it will be of 115 mm and 60 mm height. And the width or height of this face and the width of this faces we can take it from the question, which is 12 and 12 respectively. Okay, right. So now when you're going for this face, which is one curved one, so you can see it is a curved, a circular surface. Okay, this is a semicircular surface and this is a circular surface. So this pertains to a hole here. There is a through hole here. Okay, so whenever you are gonna take the circular surfaces, first we have to plot the center of this curved surfaces. Okay, so look at here. This center is 23 mm from this face, the inclined surface. Okay, 23 mm, and the other reference you can take is from here. Okay, from this leftmost end, it is the distance you can calculate here, as or no. So this total diameter is 50. So this distance will be 25. So 25 mm in the x direction from this point and 23 mm in the y direction above. Okay. So let us plot the center point here. For this will be 23 mm in y direction and 25 mm in x direction. So the reference will be taken from this point. So this point is this one. Okay. So with this center, okay, you have to first draw this curved surface. So here, look at here the curved surface. Till this point, it is vertical. Both the faces are vertical. And after this point, this makes a semicircle which is of 50 mm in diameter. Okay, like this. So till this, it is vertical, and from this, we can take this diameter to be 50. Okay, so when you look at here, this height will be 20. This height will be 25. So no, this height will be 25. So if you add up this 25 plus 23 plus 12, it will be coming 60. Okay, so this height is 23, so 25, 23, and 12. So total will be 60. So if you are draw it right, so this the topmost point of this curved surface and this height will be on the same line. Okay, then draw the hole here, which is 25 mm diameter at the same center. So at the same center, draw the hole which is 25 mm diameter. Okay, so this makes your front view. So now let us go to the top view. So now to get to the top view, project all your available edges onto the top view side here. Okay, similarly when you're doing so, please do also project the ends or extremes of your circles as well. So that will be marking you the boundaries of the circle. Okay, so this, if you're projecting these lines will be able to get the top view of the cylinder. It is like a cylinder, as well. The whole here we can assume like as a cylinder which is of this much diameter and this much length. So here length is 20 mm. Okay, so let us see how it has been done. So okay, so when you are looking at the top view, the faces will be visible are this face, okay, and this face, and the top of this curved surfaces. Okay, so this face will be 60 mm in length, which I have already taken. So this width I have taken along with this projected line itself. Okay, and similarly when looking at this face, you'll be having an inclined surface upon which you'll be getting the top view of this curved surface, which will be looking like a rectangle. That's all. like this. So the length of this rectangle will be 20 mm, the width. Okay. So within this rectangle, so within this curved surface, there is a hole which is running through. Okay. So that will be given as a hidden line. So this is the extremes of the hole. Okay. So this is the diameter of the hole here again, which you can take it from here. Okay. So the hole will be running through this region. Yes or no? So which will be giving it as a hidden line. So this marks you the top view of the hole which is hidden. Okay, so yes, so that's how your top view is finished. Now in order to get to the side view, so we are going for the left side view here. So left side view will be drawn, will be seen from here. So since this is a first angle position, the left side will be drawn on the right side here. Okay, so when you're looking at this position, so the face which will be visible again will be having this surface which will be looking like a, which will be looking like a rectangle here. Yes or no? And this inclined surface and this surface. Okay. So look at here, when I'm drawing this surface, you can easily get it. So this is the height here. Okay. So like, let us see how to get it. So now project all these points. Draw a line which is for 45 degree with your horizontal. Project the all available lines horizontal towards this 45-degree line and project it vertically upward. Similarly, project all the available lines from your front view onto this side view. Right. Now what about so now within these projected lines I'll be plotting my left side. Okay, so let us see. For first, let us go for this surface which will be looking like a rectangle here. So this will be height and this is how your views will be looking like. Yes or no? From the bottom to the top, so this total height will be 60, which is equal to this height. Alright, next we'll be seeing this surface. Since it is inclined, both the surface will be visible on your front view as well as in your side view. Okay, but only to the limited length. Okay, so which I can take it from this point. Okay, and before that, do the whole view also here. So here also this hole will be viewed as a hidden one, which runs along through this length. The length is 20, which I have taken from here. Okay, and the surface. Okay, so with this, your things comes to an end. But one point which I have to look here is this particular edge. So this particular edge runs from this point to this point. Is that right? Okay, so till the point which reaches here, it will be aligned with this edge. Okay, till the point as light where it falls, as the moment it falls behind this curved surface. So here you can see this edge as a hidden region along this length, so which I given here. Okay, so this completes your left side view. Okay, so after completion of your all your views, make sure you are removing the unwanted projection so that your drawing will become a tidy one. Okay, so erase these push points, also erase these unrequired lines. Alright, then name the views and make sure all the dimensions here are in mm.